Okay, so we're gonna go to page 444, which is chapter 12, and look at figure 12.3. Okay, so we're looking at figure 12.3, structures in a typical neuron. That's page 444 in your textbook. And the direction that information travels in this neuron would be from the dendrites to the cell body to the axon, and it finally reaches the synaptic knobs down here. See these? And then it releases the neurotransmitter and is received at the synaptic vesicles, which is these. You can see those.
Oh, they're all pretty low.
Okay, so we're going to talk about the synaptic knobs, which is these. And we're going to talk about the synaptic cleft here. The synaptic knob is terminal endpoints on the neuron's axon, and they're filled with vesicles that contain a neurotransmitter. And when an action potential arrives at the synaptic knob, calcium channels open in the plasma membrane, and that causes the excitosis of some of the vesicles, and their neurotransmitter is released into the synaptic cleft here. And the synaptic cleft is the small gap between the two neurons across which the neurotransmitters are sent. So it's like right here, if you can see it. It's a small gap. Okay, back on page 444, looking at this same figure 12.3, structures in a typical neuron, we're going to look at the receptive segment, the initial segment, the conductive segment, and the transmissive segment of the neuron. And I'm going to actually flip to page 456 and look at figure 12.12 to better show you these segments. So we're going to start with the receptive segment right here. And the dendrites and the cell body are considered the receptive segment. They receive stimuli to excite the neuron. The chemically gated channels such as cation channels, potassium channels, and chloride channels are found here, and there's no voltage gated channels here in the receptive segment. So that's the dendrites, which is these, and then the cell body. That's what makes up the receptive segment. Moving on to the initial segment, and that is the axon hillock, which is this right here. That's considered the initial segment. And the conductive segment just below is the length right here of the axon. Both contain voltage-gated sodium channels and voltage-gated potassium channels. In these segments, graded potential are processed and nerve impulses initiated, and then there's, in the conductive segment, it conducts action potentials. Lastly, transmissive segment, which that includes the synaptic bulbs or knob, whichever you prefer to call it. It has voltage-gated calcium channels and pumps, and in this segment, neurotransmitter is released from the synaptic vesicles. After the nerve signal gets to the synaptic knob, which then has excitatory or inhibitory effect on a neuron, muscle, or gland. Okay, so turn to page 467, and we're going to look at figure 12.19, showing the events of an action potential. And so to start, we have the cell at resting membrane potential of negative 70 millivolts here. See? Sorry for the glare. And then the cell becomes excited. The threshold is then reached. Next is the depolarization phase here. And sodium rapidly goes into the axon, which makes the polarity go down from negative 55 millivolts to positive 30 up here. Then next we have repolarization phase, and that is when voltage-gated sodium channels close and voltage-gated potassium channels open. And polarity is reversed again from negative to positive, and that would be from positive 30 millivolts here to negative 70 millivolts. See, back down. Next, hyperpolarization occurs when the voltage-gated potassium channels don't close quick enough, or they stay open too long, and a lot of potassium leaves the axon, causing the membrane potential to be less than the resting membrane potential. So you'll see it's below the original resting membrane potential. Then lastly, the voltage-gated potassium channels close and resting membrane potential returns by sodium-potassium pumps to negative 70 millivolts. Okay, so in regards to the different lobes of the cerebral cortex, there is 4, and those are the frontal, parietal, temporal, and occipital. And they each are responsible for processing different types of sensory information. So let's start with the frontal lobe, which is in the anterior, in the front of the body, toward the front. And we're going to do, the frontal lobe is here. And then the parietal lobe is going to be just past that. Go to the side. Parietal lobe is right here. And then in posterior, or toward the back, you have the occipital lobe. And then on the sides here, and then over here, is the temporal lobes. So the frontal lobe concerns voluntary motor functions, concentration, verbal communication, decision making, planning, and personality. The parietal lobe is involved with general sensory functions regarding the location of body parts and interpreting visual information and processing language and math. The temporal lobe is hearing and smell, and the occipital lobe processes incoming visual information and storing visual memory. Okay, so I have my lovely assistant here, and we're gonna point out the axillary nerve, which is right here. And the axillary nerve innervates the deltoid and teres minor muscles, and it collects sensory nerve signals from the superlateral part of the arm. Okay, so next we have the median nerve, which extends along the midline of the arm and forearm and deep to the carpal tunnel and wrist. And so that is going to be here, the median nerve. And it innervates anterior forearm muscles, the femur muscles, and the lateral 2 lumbricals. It receives sensory nerve signals from the palmar side of the lateral 3.5 fingers and the dorsal tip of the fingers. Okay, so we're gonna show the musculocutaneous nerve now, which innervates the anterior arm muscles that flex the humerus and forearm, and it also receives sensory information from the lateral part of the forearm. So the musculocutaneous nerve is going to be here, right here. Okay, so from here, we're in the posterior position, and we're going to show the radial nerve, which stretches along the posterior side of the forearm and the radial side of the forearm, and it innervates the posterior arm muscles and posterior forearm muscles. It too receives sensory nerve signals from the posterior arm and forearm and the dorsolateral side of the hand. So the radial nerve is here. It's kind of hard to, right here. Okay, now in the anterior position here, we're going to show the ulnar nerve, which is along the medial side of the arm, and it innervates some of the anterior forearm muscles and most of the hand muscles. It receives sensory input from the skin of the dorsal and palmar areas of the pinky and half of the ring finger as well. So the ulnar nerve is going to be, go inside, turn your arm this way a little bit, right here, right there. Sorry. Okay, we're lastly going to show the femoral nerve, and it innervates the anterior thigh muscles and receives sensory input from skin of the thigh and the medial aspect of the leg. And so the femoral nerve is going to be like here. You can see. Excuse the mess.